Good morning, students. Welcome to Good Samaritan School online classes. Yesterday's class we learned about modern periodic table, who constructed the modern periodic table, and what is the modern periodic law, and also we have learned these things we have learned, and also we learned about how this each and every elements are constructed based on atomic number, right? And also groups, how many groups we have in the modern periodic table and how many periods we have in the modern periodic table. And also we have seen that some of these importance like group names. First group, alkali metals, alkali earth metals, right? Boron family, carbon family, nitrogen family, chalcogens, halogens, noble gases or inert gas. So we have seen the names, right? And also we'll say we have looked some of the importance also. Today class we are going to learn even more detailed things what is present inside the modern periodic table, right? The first thing is, you can see, except hydrogen which is present here, except hydrogen, all the elements which is present on the left hand side of the periodic table all are metals. Secondly, whatever you can see here on the right hand side, on the top, most everywhere are all said to be non-metals. Mostly you can see some of them are all gases, right? And also you can see a pink line which is given here in a zigzag. All these are metalloids. You know what is metalloids and non-metals. Metalloids are nothing but they have the properties of both metals as well as non-metallic characters. Okay. And also we have seen today's class even more we are going to learn about these elements present in this periodic table. Say an example, the two pillars we can see in the left hand side, the first group and second group, we are going to name this as S block element. What is that? S block. S block. Okay, try to give a name. And the block which is, these are all like a building, right? The block from 13 to 18 are all said to be P block. Okay, P block element. Okay, I will give you a complete explanation why it is given S block, P block and all. And the elements which is present between 3 to 12 are all said to be D block. D block elements. Okay, so S block, P block, D block, right? And we have a name for this group which is present here from 3 to 12 are all said to be transition elements. Transition means it is present between S and P. That is why it is transition elements. Okay, there are, you can see here below the periodic table we have two special columns are there given here, two special groups, and these two are nothing but lanthanides and actinides. What are they? You can look at carefully here and in page number this, if you 86, 57. If you are looking at this 57, there is a star is given here, and also 89 there is a star, two stars are given. And these two groups, that means in between that 57 or 57 to 58 to 71, there are many elements are there, they can't keep it here, so they gave us special places for them. Same for actinides also. Most of these elements are radioactive in nature. All these are named according to some of the scientists. You can watch carefully, cerium, and I just want to tell you few names of scientists which is named based on scientist. For example, here 99 Einsteinium, this element is named because to honor the scientist Einstein, Albert Einstein. And then Lawrencium, Nobelinium, Mendelevium, Mendeleevs, okay, Mendelevium to honor them, Mendelevium, Curium to honor Marie Curie, right? Plutonium, uranium. So all these elements are all mostly radioactive elements, right? So these are some of these very important thing you should know. Okay, And I want to give a name for this also. These two are nothing but F block elements. Okay, F block. And because these lanthanides and actinides are present inside the transition elements, they are named to be inner transition elements. Inner transition elements. Q inner transition element because these two are present inside the transition elements. Understand? Okay. But in our topic, we don't have S block, P block, D block, and F block elements. But anyway, we should know about this because it's one of the important thing when we go and learn in 11th standard. You will be learning on that. Okay. Let's move on to what we are going to learn today's topic. In modern periodic table, as it is given like this, I made a rough figure of modern periodic table. I hope you will know what is all these elements name, right? S block elements, P block elements, D block elements, and F block elements, right? Okay. This modern periodic table, there are many functions we are going to learn today. What are they? About valency. The first one is about valency, and the second one about atomic size, right? The third one is metallic and non-metallic character, and these things we will be learning in the coming topic. Okay, what we are going to learn about valency. As we all know about valencies are nothing but the number of electrons present in the outermost shell of an atom. Okay, and if it exceed more than 5, that means you have to minus that with 8. Okay, this you all know about valency. How this valency is playing an important role in this periodic table. Let's see some example here. If you see, look at the example of lithium. I'm going to write it here: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. If you see these valencies of the element, because lithium has atomic number 3, the valency is, because they have a first shell में 2, second shell में 1 है, तो the number of these 3 elements or these 4 elements valency depend upon their valence electron itself, because they have 1 in the last shell, so 1 is the valency. Beryllium atomic number 4, so 2, that means 2 is the valency. And boron atomic number 5, so 2, 3, that means 3 is the valency. Carbon atomic number 6, so 2 and 4, that means 4 is the valency. But after this, from nitrogen, oxygen, fluorine, and neon, because they have more than 4, this we cannot take it as valency. That is going to be considered as that means outermost shell 5 comes, so 5 minus 8, it comes 3, so 3 is going to be the valency. And for oxygen 2 is the valency, fluorine 1 is the valency, and neon 0 valency. If you watch carefully all these valencies, they started to increase and they started decrease, right? So lithium valency is 1, beryllium valency is 2, and boron valency is 3, carbon valency 4. But when you start looking at these 4 elements, it comes 3, 2, 1, 0. So this is what the valencies looks like. That means they steadily increase and they started decrease as we go down, and they also finally it becomes 0 in the noble gases. This is how valency looks. This is across the period. This we can see only across the period. So if I say about valency separately, we'll write it here. That means as we go along the period, the valency increases and decrease steadily. Okay, that means increases from 1, 2, 3, 4, and then started decreasing to 3, 2, 1, 0. Clear? This is what happens in the valencies along the period. This is very important, along the period. What happens along the group? Let's see the valency of the group. If you watch carefully, all these valencies of elements in the group all are have same valencies. You can look at lithium, sodium, potassium, whatever elements comes below that, beryllium, magnesium, calcium, or whatever elements comes down, all are having same valencies. So I can write it here. I can write it like this: elements of group, elements of same group has same valency. This is very, very important. Clear? So what we learn from valency? As we go along the period, the valency may increase and then decrease steadily. How much they will increase? Increase up to 4 and then decreases steadily to 3, 2, 1 and 0. Finally ends with 0. And 0 किसको आता है? Because noble gases का valency 0 होता है. And group में कैसे आएंगे? All the elements as we see in the group all have same valencies. You cannot see any different valencies. Clear, student? The next topic we'll be going to learn is atomic. Atomic size. What is atomic size? It represents the radius of an atom. For example, this is an atom and nucleus is present inside. That means the distance between the nucleus to the outermost shell of an atom. Okay, this is what the radius. In other words, atomic size भी बोल सकते हैं, or in other words we can say that as atomic radii. Atomic radii. Okay, we can say anything. Atomic size is nothing but the distance between the nucleus to the outermost shell of an atom. Okay, let's see how the size of an atom will looks or along the period. First we'll look at along the period. One thing you have to look at carefully. As we see examples of lithium, beryllium, boron, whatever it is, you can take the third period also. Sodium, magnesium, aluminum, silicon, all these things. You can look at very carefully. They all increase by one atomic number. Am I right? Sodium atomic number 11, magnesium 12, aluminum 13, silicon 14, 15, 16, 17 and 18. That means all are increased by one electron, because atomic number 11 है तो electron also 11, right? Atomic number 12 है तो electrons also 12. So all these elements have same shells. That means all these elements, that means elements or electron which is present in these elements are all are present in the same shells. I just want to tell you here. Okay, let's talk about sodium. Okay, I just want to make a sodium structure. This is the nucleus and sodium का atomic number क्या है? 11 होता है. So first shell 2 electrons दे दिया, and then second shell we are giving 8 electrons. Am I right? And third shell sodium consists of only 1 electron. Clear? Okay, what about sodium के बाद? What is the along the period, what is the next element comes after sodium? Yes, it is magnesium. Okay, magnesium atomic number is 12. Sodium का 11 होता है, इसका 12 होता है. And the two shells, they have the same kind of elements, right? First shell 2, second shell 8, and then the third shell 2 electrons. You see that first shell K, L, M. First shell K, second shell L, and third shell M. See that in M shell sodium consists of 1 electron, and the same M shell magnesium consists 2 electrons. Am I right? And what is the aluminum? Aluminum atomic number 13. I don't want to draw all these things. You can draw in your home. and I'm going to draw the last shell. Okay, I'm going to draw the last shell, which consists of 3 electrons. This aluminum consists, and this 3 electron in the M shell. Am I right? So as we go on like that, sodium, magnesium, aluminum, or silicon, or phosphorus, as we go like that, all these elements and the electron which is present in these elements are all in the same shells. See that? So how the size looks? The size, they started to decrease. I can write it here as the number of electrons increases, size of an atom decreases. It's very, very important. Very, very, very important. So as the number of electron increase होता है तो size of the atom automatically decrease हो जाएगा. Why it needs to be decreases? You think of that. Only one electron in the outermost shell. So the nuclear charge which is present inside the sodium, you think of the sodium first. Okay, the nuclear charge which is present inside the sodium, they have enough power to hold the last electron. So last electron को ऐसे पकड़ के रखता है, खींच के रखता है. You think of that. If one more electron is added, like magnesium, this proton which is present in the magnesium giving even more power to hold the 2 electrons. And if the number of electron increases in the last shell, so as the nuclear charge is also spending most of energy to hold all the electron which is present on the last electron. You think of that. If the size बढ़ के जाएंगे तो this nuclear power, or we can say the nuclear charge, has to spend more energy to hold all the electron. खींच कर रखना पड़ेगा ना. For think that this is, and this my hand is the nucleus and these are the electrons which is present. If number of electron increasing, then I have to spend some attraction force to come closer. खींच कर रखना पड़ेगा. Am I right? So what this nuclear charge they done is, as the number of electron increases, automatically the shell का size थोड़ा सा खींच के nucleus के पास आ जाता है. Will you understand? That means the size started shrink a little. So comparing sodium, magnesium size is little shrinked. क्यों? 2 electron increase है ना, shrink हो जाता है. Aluminium even थोड़ा सा और shrink हो जाता है. Silicon even थोड़ा और shrink हो जाता है. And when you go to phosphorus, even more it started shrink. Will you understand that? Chlorine, even more they started shrink. So the size of the atom automatically started shrink. For example, if I say sodium size is like this, magnesium size is little smaller than that, and aluminium size even more smaller than that. And then if I come to silicon, even more smaller, and then phosphorus even more smaller, sulfur even more smaller, and then when you go to chlorine, smaller, and then when it comes to another last one, then it becomes smaller again. So if you compare the size of the atom as we go along the period, because all the electron needs to be attached with an electron, size automatically shrinks. Even if I want to explain, I can explain like this. The increase of proton in the nuclear causes larger attraction for electrons, right? Due to increased attraction of electron are pulled closer towards the nucleus, right? This causes a decrease in the distance between the nucleus and the outermost shell, and hence the size decreases in the period as the atomic number increases from left to right in the periodic table, right? As the number of atomic number increases, atomic number increases from left to right only. right? So as the atomic number increases, number of electron increases. As the number of electron increases, size automatically decreases. Will you all able to understand this, student? Right. And the last thing, as we go down the group, okay, group में जाएंगे तो क्या हो जाता है? As we go down the group, let's see some example of sodium. Sodium के नीचे क्या होगा? Potassium. Okay, sodium के ऊपर क्या होगा? Lithium. Let's compare these three elements. Lithium, atomic number 3. So how they looks? First shell, 2 electrons. Then second shell, only 1 electron, right? So 2, 1 electronic configuration. Sodium, atomic number 11. So 2, 8, 1 electronic configuration. So if I want to draw the structure of sodium, I can draw like this. First shell 2 electron, second shell 8 electrons, and third shell 1 electron. And if I want to draw for potassium, what is the atomic number of potassium? Yes, it is 19. So 2, 8, 8, 1. This is the electronic configuration. So how to draw the structure of this? So first shell 2 electron, second shell 8 electrons, and then the third shell again another 8 electrons, and the last shell 1 electron, right? So if you watch carefully, as we go down the group, lithium का देखो Kl, right? Only 2 shells. And sodium का देखो Klm, 3 shell हो गया. And potassium का Klmn. That means the number of shells increases. As we go down the group, number of shells increases. So the size of an atom also increases. I hope you understand. So as we go down the group, number of shells increases. If number of shells increases, though, automatically size will increase. Okay, student. Today what we learned a few things, and which is very important for us. One thing is about what this periodic table is made up of. Like it made up of some S block, P block, D block, and F block elements. And mainly we have learned two things today. One is valency, how the valency of element present along the period as well as in the group. And also we learned atomic size along the period, how the atomic size varies, and also along the group how the atomic size varies. Okay, student, this is what the class this is what we have learned today, and tomorrow we'll be learning some more examples and some more topics. Hope you understand this. If you have any further doubt, please do ask me in my WhatsApp number. Thank you, student, and have a nice day.